were required to accommodate the tube channels and control rod passages. The pile required 2,000 tons of machined graphite blocks, bored to permit installation of the 2004 aluminum tubes. Each block had to be tested for purity using neutron absorption measurements. Blocks showing even slight neutron absorption were rejected. The reactor core would be surrounded by a biological shield, a massive concrete structure 7 feet thick designed to absorb radiation and protect workers. This shield would be enclosed in a steel containment structure measuring 46 feet on each side and standing 41 feet high. But the biggest challenge was still ahead, controlling a chain reaction that, left unchecked, would destroy itself in seconds.
A nuclear chain reaction, once started, doesn't want to stop. Neutrons split uranium atoms, releasing more neutrons, which split more atoms, releasing even more neutrons. Without control, the reaction would accelerate exponentially toward meltdown within seconds. The B-reactor's control system used 3 different mechanisms, each serving as a backup to the others. First, 9 horizontal control rods made of boron steel could be inserted into channels running perpendicular to the fuel tubes. Boron absorbs neutrons extremely efficiently. Push the rods in, and the reaction slows or stops. Pull them out, and the reaction accelerates. During operation, these rods would be positioned to maintain steady, controlled reaction rates. The horizontal rods were approximately 20 feet long and moved on electric drives controlled from the central control room. Operators could adjust rod position in small increments, allowing precise control over reaction rate. Second, 29 vertical safety rods could drop into channels through the top of the reactor. These were the emergency system. If anything went wrong, if the reaction started accelerating too quickly, operators could release these rods, which would drop by gravity into the core within 2 seconds, flooding the reactor with neutron-absorbing material and stopping the reaction immediately. Third, as a final backup, the entire reactor could be drowned by injecting a solution of cadmium salts into special channels. This was the absolute last resort, because flooding the reactor with cadmium solution would essentially poison it permanently. The control room, located in a shielded building adjacent to the reactor, featured instruments that would look familiar to modern nuclear operators. Dials displayed